We're going to work a bunch of power problems, and here they are. I'm going to hand this out in a few minutes to you. And there's 12 of them. These first 6 are pretty straightforward, and then the next 6 require a little more problem-solving capabilities and so on, so a little more challenging. And I want you to demonstrate good problem-solving technique when you solve those problems. And the technique is as important to me as you getting the right answer. So, show your work properly. And then, now we have a couple of formulas that that define quantities that we've been dealing with. One of them is work. And we said that work was equal to force times displacement. And we had variable names that we used to represent that. And then we did say that if the force and the displacement are in the same direction, you're doing positive work. If the force and displacement are in opposite directions, you're doing negative work. Then we defined power. And power, we said, was the work done over time. Or you can also think of power as the energy that gets used up or divided by time. Remember that work is just energy being transferred through a force. And energy can be any way of transferring energy, like through electricity or sound or whatever. That'll be okay. And so power equals work over time. Now, whenever you have a formula like these, you can manipulate those formulas to solve for an unknown. Like, let's suppose that if I give you the force and the displacement, you just plug them right in. The formula is already solved for your unknown if you're solving for work. But what if I want to solve for force? I mean, if they want to know how much force was applied, you would just say, well, work equals force times displacement. And if you want to solve, if force is your unknown, you just divide both sides by delta x, which algebra lets you do. Delta x divided by delta x is 1, so it cancels out. And you get force is equal to the work done divided by my displacement. Okay, simple algebra 1. Now in this case, what if I wanted to solve for the work done or the energy used? I would just multiply both sides of this by time, and the time would cancel out, and work equals power times time. And then what if I wanted to solve for time? I would say time equals time equals the work done divided by power. How did I get that? Well, if I want to solve for time, I have to get rid of it from the bottom, multiply both sides by time, and then divide both sides by power. This cancels this. You're left with work over power, and here you're left with time by itself. There are little tricks you can do and put it on an equation list before a quiz or something. You can do this. For work, you can say work equals force times displacement. And now look what you can do if you, let's say you want to find delta x. What do? Cover up the delta x, and it's work divided by force. What if I want to find force? Cover up the force, it's work divided by displacement. What if I want to find work? Work is force times displacement. And then the same thing is true here. I can put work equals power times time. And the same thing here. Power, if I want to solve for power, cover it up. Power equals work over time. Time equals work over power. Work equals power times time. So these little triangles can help you. And now that we've got work and power and so on, I'm going to create a little, I call it a quantity chart, and it helps you keep these things organized. So we want the quantity, the variable, and the units in my quantity chart. So one quantity that we use is force. The variable we use is F. And what are the units that we use for force? Newtons. Now we can also use pounds, but that's just a unit conversion, and I'll put a list of unit conversions after this. Then we have displacement. Which we use delta x for. Sometimes we use delta y if something's being lifted up or down. You'll see some books using delta y for that. That's okay. Use delta y if you like. I'm just going to use delta x in this class, though. And the units are meters. And then work. In joules. And then, of course, we have power. Oh, wait, time. We use lowercase t for time. And we're going to measure time in seconds. And then we have power, which we use the letter P, and we use the letter W for watts. And then we have the formulas that we need. Work equals force times displacement. Power equals work over time. And then we have units. A joule is a Newton times a meter. A watt is a joule per second. So this is just to kind of summarize everything in a little chart here. Make it easier to solve these problems. Now when you solve these problems, I want you to use good technique. You don't have to copy down the problem, but you do have to use given, find, and solve. Then you have to check the units. Make sure everything is in these units. If it's not, you have to convert them to those units. And then write down the formula. And then solve the formula for the unknown. Then plug in your numbers with units, your values with the units, and then you have your answer with a box around it. So I want really, really good technique on these. So in your notebook, let's do number one. So we are We are doing the assignment now. Number 1, given. Now, sometimes I'll draw a picture if a picture helps me understand the problem better. This is just a motor that does a certain amount of work in a certain amount of time. I think a picture here is not necessary. A motor can do 1,000 joules of work. So the work is 1,000 joules in 5 seconds. What is 5 seconds? That is T equals 5 seconds. So I want you to express what's given in terms of the variables, the value with the units. Find. How powerful is the motor? So what are we trying to find? Power. And we express that with the letter P. Let's solve it. Now you look at your list of equations and what relates what we know with what we want to know. Power equals work over time. I'm given the work done, I'm given the time. So power equals work over time. Always write down the formula. You write down the formula before you plug the numbers in. Why should you do that? So you'll get full credit when I grade your quiz or when I grade your notebooks. That's one reason. But a better reason is that if you show good technique like this, someone who looks at your work later can tell what you did. And that someone could be you. Weeks later, studying for the semester, the first semester final exam, and you want to know what you did. It's right there, and it looks good. But now you can plug in your values. So what is 1,000 divided by 5? It's 200. How did I get 200? Just cover up the 2 zeros. What's 10 divided by 5 is 2, and add 2 zeros. What is a joule per second? It's a watt. So P equals 200 watts. So this is a very simple problem. There will be problems where you need to do a little bit more work than this. For example, what if we were trying to find work here? You would write this formula down, and then you would solve it for work, and then you would plug in your values with your answer. What if you were given something in pounds or in minutes or something like that? You would have to change those given values into these units here, because these are the units we're going to use. Okay? So again, this is going to be an assignment that's really easy for you to lose points on, because when I grade your notebooks, I'm going to be looking for good technique, not necessarily the correct answer. So I'm going to give this to you now, and then while you're working on it, if you want me to check your technique, I will take a look at it and tell you what you need to do to improve it. Okay? That is all.